My name is Mark Allen, and welcome to the Meetup tonight. We're going to kick things off here. Terry Lewis is going to do our presentation tonight. It's about functional reactive programming in iOS. I'm really looking forward to this because it's something I've been interested in, but really haven't had a chance to explore very much. And just for everyone that's on the live stream, welcome. And everyone here in the room, welcome. Are you ready to go? Yep. All right, cool. All right, so take it away, Terry.
All right. Hello, everyone. My name is Terry, as I said. There's my Twitter handle if you feel like following me. So we're going to be talking about reactive code. And this is in the context of writing iOS or Mac OS X apps, but I focus more on the iOS side. I'm assuming most people in here haven't done much Objective-C, so we'll do a little primer because we're going to be looking at a lot of Objective-C code. So Objective-C is a superset of C, so you can write C. Whatever C you want to write, you can write it in your Objective-C programs. But this is bringing more object-oriented stuff based on Smalltalk, so forth. I mean, it's a regular imperative language. It's not much different than Java or C# or Ruby. And it's nothing you haven't seen if you've done any of those. It does have some weird syntax. You use brackets for message sending. You don't use parentheses. So, full overview, you have the class, which starts with uppercase and it's prefixed. You have the pointer syntax, the name, which is a string. You have a class method, which is alloc, and init, which is an instance. And that's just the basic how to create a class and create a variable. Alloc and init is the default initializer you will usually use. So yeah, the brackets is probably one of the weirdest things to get used to if you're coming from Java or C#. You only see parentheses if you're working like lower C functions. So brackets are for message sending. And classes are prefixed. You'll see a lot of things with NS that comes from, I believe, the next step. Yeah. So a lot of their foundation classes, NSString, NSArray, NSDictionary, so forth and so on. If you write your own classes, you should prefix them because there's not really any namespaces. And you also have named arguments, which I don't know any. I can't think of any other language that really does it like this. So. Yeah, well, yeah, a Smalltalk. Yeah, so you have some message, an argument, another arg, the other argument, another argument, so forth and so on. So you might have very, very long methods. So that's another weird thing you might have to get used to, but it's the object, the message, colon, the argument, the rest of it, the colon, the argument, so forth and so on. And NSObject is the base class of all objects, but you won't actually use it much like you might in, say, Java or C# where you have object, and you use that for maybe polymorphism. You have this special type called ID, which is basically just saying any object. So anytime you want to do a polymorphic function like a map function, you would say it returns an ID, and the object in there is an ID. So you need to know that NSObject is a base class, but for anything that you want to say, any type of object, you use ID. Yeah.
Does it have to be units or do we all have to be the same function?
No. Collections are.
Can you just repeat the question real quick?
Yeah. So the question was, I guess, can collections have any type of objects?
Yeah.
Yeah, you can put any. If there aren't any generics, you can shove whatever you want in your collections there and type it all, which is not very good, but that's just the way it is. So, I mean, in practice, you usually don't do that, but you can. So there's any type of object you can throw in a collection with any other type of object. They are not from that. There are no generics. So, and you do have closures, anonymous functions, whatever you want to call them, as we just saw previously. This right here, it's a very weird syntax. You have the return type, this little caret, the parameters, a bracket, the actual code, close bracket, and then close square bracket, close off the original method. And this is an anonymous function, and in the map function, it would grab this, run it, and dump that object into a new array. And we usually call these blocks in Objective-C. Nobody calls them closures or non-closure. Blocks too? Yeah. So blocks is the standard nomenclature. You'll see this a lot in Reactive Cocoa. So it's something good to get used to. You can get, it's maybe a little out of scope, but you can't retain cycles because this isn't a garbage collected environment. It's a reference count. So you can get retained cycles if you reference like self within a block. That's great on self, but not too much to worry about. Right. Yeah, you'll be using a lot of these blocks in Reactive Cocoa. So, just a very short introduction. You'll be seeing some more code. Getting on to it. Reactive Cocoa is apparently not functional reactive programming. I discovered this like 2 days ago. I don't know if anyone's heard of Kunal Elliott. Apparently, he sort of invented functional reactive programming. He has a system called Fran. But apparently, this is not functional reactive programming. It was inspired by it. Which, again, I found this out 2 days ago, and the people that created this sort of agreed with that. So we're saying this is inspired by it. And we won't really get into exactly what it is or the differences, but for now you can just keep on calling it that. This Stack Overflow post is an answer from Kunal Elliott that says, I guess, what functional reactive programming is in its definition. So I guess, again, I just found out about this, but I guess he sort of created the idea. So,
can you go back to that?
good. All right. So, I gave this talk before, and I gave it to Objective-C developers that had never done functional programming before. And so, since I assume everyone here has done functional programming, I sort of chopped off some of the explaining sort of what functional part is. We're going to more of the reactive part, because I don't know if anyone's really done the reactive programming. So, we all know what functional programming is. The reactive part comes to change being automatically propagated in your map. And you can just think of Excel or a spreadsheet where you have your formulas, everything updates as you type in. You don't have to hit update or whatnot. And it's one of the big differences, big themes with FRP, is this automatic propagation change. And it makes for a better user experience too, which we're talking about iOS apps, and they're all about design and user experience. So you have these apps that are immediately reacting to your user's input. I mean, it's just better user experience. You don't have to have things reload, so on and so on. Just goes. So that's sort of where the reactive part comes from. And it's also immutable, at least for Reactive Cocoa. So once you get a value from Reactive Cocoa, you can't change it. And we know this is good. Again, we're all doing functional programming, and we know immutability is good because it reduces state. Again, we probably might all have a good inkling of this, but we'll sort of do a quick overview of this. And they talk about this a lot in Reactive Cocoa, like you read their literature. They talk about reducing state and side effects. So maybe you could just sort of have the sort of nomenclature and where they're coming from. I thought this was a pretty good definition. State is anything that can change in place over time. So if it's any sort of variable, you mutate it, you assign it, that's state, and it's just bad. You've got these points, and this was answered. This is taken from Stack Overflow by this guy, Justin Sparr Summers. He's one of the creators of Reactive Cocoa. And I thought this was a pretty good definition. Saying you lose past information. Once you change a variable, that information is gone. And this is a big one, especially when you're doing like iOS apps and things with GUIs. It's changed anywhere, and that's definitely going to be a big place that'll bite you. And of course, concurrency. Concurrency, immutable state do not go together. So, and this is one of the things Reactive Cocoa tries to do is help you reduce state in side effects. As I said, assignment is state. So you have a variable x, you reassign it, you just change the state. And this is how we program every day in iOS. Like this is an imperative language. This is just a normal way of doing it, but we're trying to, with Reactive Cocoa, we're trying to think about it differently, not write it in imperative style. And that's why, because state is difficult to reason about, especially with GUIs. You have, well, if this thing pops up, then do this, and have this boolean, and this other animation, and it just gets really, really hard to reason about these GUIs. You have a database populating the GUI in different states, and so we want to reduce that as much as we can. And then, again, they talk about side effects a lot, which, coming from functional programming, coming from a pure language, you don't really do this too much. But again, this is something you see in Objective-C a lot, is you have this method, and it has some global variable, and you're going to do something with this global variable inside this method. And this is again normal. You'll see stuff like this in Objective-C a lot, but we want to try to avoid this because this is a side effect. You're changing the state, and this function is going to do something, produce something different every time you call it, so it becomes difficult to reason about. And so we want to go for referential transparency, or pure functions, and not change the mess with state inside our functions. And again, just a little example of a pure function. This takes an integer, increments it by 1, or returns the integer plus 1, does not change the integer, does not rely on any outside state. These are the kind of functions we want. You know what this is going to do. You always know what it's going to do. It's never going to do something weird on you or mess with anything else. So this is what we want to deal with. And you'll see this. It's hard to think about this like this sometimes in GUIs and with this imperative language, but this is what Reactive Cocoa sort of tries to help you to do. And tries to help you make your side effects explicit too. All right. Now, this is sort of the big thing for FRP in Reactive Cocoa. The way you think about assignment is totally different. So this is assignment in an imperative language, how you currently understand it. You have an int x, you say x is 4, you say y is equal to x, and then you say x is 3, but y is still 4. And this is probably how you work in any regular language. This is not how it works in FRP, in Reactive Cocoa. Take the same thing, and this is sort of just pseudocode, and do it in FRP. You say x is 4, you say y is equal to x, then as you change x, y changes too. So it's not assignment. You're saying, when you say y is equal to x, you're saying y is bound to x. So, and this is the big thing. This is one of the key things of FRP, is you're binding variables. And assignment, we like to say assignment is assignment over time. So instead of assignment as a single point in your program, you have assignment over time. So you think about your data and how your data is split over time. And that's how your assignment works. So it really makes you think, which is sort of good bad. The great thing is it makes you think really hard about your data and its flow, and the bad thing is it makes you really think about your data and the flow. So you really have to think, like, what is the time? How is this changing over time? How do I need to manipulate it over this time? And so this is the key thing with FRP, is assignment over time. And so I'm going to go right into some code. And if y'all want to follow along, you can check out the repository. Just plop that into your terminal, into whatever directory. You can follow along if you want, or I'll just go through it up here. It really helps to see this in action and run it. I mean, for me, it did. I watched a ton of talks and heard people talk about it, but I didn't get it until I actually wrote some, and I ran it, and saw really how it was working. So this is really where you'll get the most benefit, because I could blab about things all day until you actually run it and see it, and then you're probably not going to really get it. So does everyone that want that URL have it? Got it? So, well, first one little thing. The main class that interact with in Reactive Cocoa is called Reactive. And you can think of this as a stream. We're talking about assignment over time. So you can think of your data as a stream. And a signal is a push-driven stream, or a pipe. You want to think of it as a pipe. Values are pushed onto it, they flow in one direction, and then you receive those values with subscribers. But yeah, this rack signal is what you're going to be interacting with a lot. I'll come over here. Here's a very small iOS app, and we're just going to sort of show you how this works. We have a text field that we hooked up. It's this text field sitting in view. And we have, down here, we have this wrap text signal method on the text field. What that does is it gives us a signal that will send the values from the text field. And then on that signal, we say subscribe next. And that creates a subscription, which is saying, hey, I want to be notified. I want to listen for these values, for the next values from the text field. And so this takes a block. And here we're just logging the text that comes from this text field. Down just a little bit further, we have this Pikachu string and this macro, this RAC macro. And what we're saying here is we want to bind this Pikachu string to the signal that comes from the text field. And this sort of is how I sort of thought about this recently. You can almost think of this like I/O and Haskell or something. You don't get the value out of a signal. If you want to bind something, you have to use these macros. You can't just say, give me the value out of the signal wherever you want. You can either bind it, or you can get to the value in one of these subscribe next methods, but you can't just pull the value out of it. So that's sort of how it's going to be. It's sort of like I/O in pure language, where you don't actually get to the value. You transform it and work on it. And then, just a little further down, we're using this observe method. And again, using the Pikachu string. And this is simply saying we want to observe changes to the Pikachu string. So every time the Pikachu string changes, this should get called. And again, we're just going to log it out. So what we have here is a text field. We're binding the text field to the string. And so the string and the text field should always be in sync. So we will run this. We got this app, we got this text field, this one text field. And if you pay attention to the console over here on the side, so can see we're logging the values out as they come.
Why is each state duplicated? Or like double entered there?
Because we are logging the text field text right here. We're getting a signal from the text field. And then we're observing the Pikachu string, which is bound to the text field.
Oh yeah.
So
it's logged in both places.
It's logging both, and you can see that they're both in sync. So you can sort of get a feel for how this works and how the signals work, seeing how this reacts. As you type, it's immediately firing off the subscribe method. This Pikachu string is always updated. It's bound to the signal from the text field. And as we observe the Pikachu string, you can see that we're logging the exact same thing twice. And that's because the Pikachu string and the text field are kept in sync. And so this is, I think, good for first introduction. You can see how the signal works and how you bind values or objects to other objects. See the output of that. This is kept in sync. And if you're trying to do this in normal Objective-C, you have to create either a method on the text field, or you have to implement one of its delegate methods. You have to assign the Pikachu string in there. You have to use key value observing, which is a very not fun API. And so to translate this into imperative normal Objective-C code, it wouldn't be terrible. I mean, it's a small example, but it's a lot uglier and a lot easier to use. And here you have, basically, if all you want to do is bind the Pikachu string, you have one line. This RIC self Pikachu string equals self text field dot RIC. So that's all you have to do to create a binding between two objects, and it'll keep them up to date with each other. And so you think of the Pikachu string as a subscriber that subscribed to the values from the text field. So it's like, hey, I'm invited to listen to these values. And a signal can have multiple subscribers, any number of subscribers. So it's not like you can only have one thing listen to one signal. You can have a million things listen to one signal. Or vice versa. Well, not vice versa. Yeah, you can have multiple subscribers. And so again, values from the text field are pushed onto the signal, and they're pushed right to these subscribers. So every time a value comes on, pushed onto the signal, it says, oh, there's a subscriber, let me give it this value. And we log out that value. Same thing with the rack observe. Rack observe is just a macro and creates a signal from this string, the object, the Pikachu string. It creates the signal itself, and then we say we want to subscribe to those signals values, and that comes out as the same values in the text field since they're round. Right. 2. Again, you can see long Objective-C methods. Anyone got any questions? Everyone good?
Do you happen to know under the hood, is it just binding to the normal delegates, or is it?
For the text field, it creates a target action. It's not using the delegate, but some of them will create their delegate and so forth. But yes, I mean, this is written in Objective-C, so it's not like some voodoo magic. So if you know Objective-C or iOS, you can go see how they're doing it. It's not like simple. It's pretty advanced stuff, but it's not impenetrable. So next thing is to address signals a little more. And signals and subscribers. So when we talk about subscribers, And now a subscriber is anything that registers to receive events from a signal. And there are two types of signals. You have hot signals and cold signals. And those signals are cold. And what that means is that the signal will not do any work until it's subscribed to. So you can create the signal, say, do all these things, and send all this data, but if you never subscribe to the signal, it's never going to execute anything. It's just sitting there waiting for someone to subscribe to it. A hot signal, on the other hand, will do its work immediately. Like you create it, you say, do this work, it's going to do that work, and even if it doesn't have a subscriber. So it'll do its work, and if it doesn't have a subscriber, it'll just do its work and do nothing. So, but usually you deal with cold signals. Yeah, and there's a basic way of creating a signal. You have this rack signal create signal, cold signal. You also have rack signal return, which just injects the value into a signal, which maybe that looks familiar to some people. That's also a cold signal. And as I said, there's a hot signal, which will do it immediately. And you know when you're creating a hot signal, because they usually say start eagerly. So if you want to create a hot signal, you use the start eagerly method. So you can see how this works. Again, we have a cold signal here. We use the normal rack signal create signal method. And we say, we get the subscriber in here. We say send next, Pikachu, and then send complete. And then we take this cold signal and we subscribe next, and we log out the value. We have another signal. Same way, create signal, send next, I'm cold. We log inside the signal block. And then we have a hot signal. So you can run this and watch the console output. So we log Pikachu and Squirtle. So we log Pikachu right here. So we have this cold signal. We say subscribe next. And then we have this value, Pikachu, and we logged it out. We had this hot signal, which didn't have any subscribers. It was just started. And we just did a simple log statement here. And you see we logged Squirtle. We have this cold signal up here, which is supposed to send a value of I'm cold, and has even a log statement in the block. And you see it never got logged. So this log never got executed. It'll just sit there and do nothing forever. So that sometimes will keep me, I'll be like, why is this not doing anything? And it's because I wasn't subscribing to it. So you just need to be cognizant of the signals and whether they're hot or cold. And we're going to scheduling. Now, this is a really nice feature of Reactive Cocoa, I think. So pretty much every time you create a signal, it's going to do its work synchronously. It's not doing some weird background and stuff. But you're obviously at some point you're going to want to do some work asynchronously. And compared to the normal Objective-C way of doing asynchronous work, which is either a low-level C API like Grand Central Dispatch, or NSObject, which is higher level but still blocked. You're still managing all this concurrency stuff a little bit. Rack's signal has this method called deliver on. And so it does what it sounds like. It will deliver the results on a schedule. So let's go look at some code. So we have a signal here, which we're creating in the normal way, and it's called the main thread signal. And we have this thread, we have this string Pikachu, and we have this little if-else statement, and we can tell we're on the main thread. And so we log if we're on the main thread. And then we send the Pikachu. And we subscribe to the main thread signal, and we log in whether or not we're on the main thread. Then we have another signal, which is created the normal way. And then we call deliver on that signal. We say deliver it on the scheduler with priority, next scheduler with priority background. It just says put it on the background queue. So first we create the signal, and then we call deliver on. And then deliver on just returns the signal. And so this is the signal we have here. It's background thread signal. So again, inside the block, we log if we're on the main thread or not. And we subscribe to the signal, and we log whether we're on the main thread. Then we have another signal. We're going to say start lazily scheduler, and we say start with the background scheduler. Again, log main thread or not. Then we take that lazy signal and we say deliver on this main thread scheduler, log it out, and see if we're on the main thread. So you can run this. So down here, Pikachu, the signal block was executed on the main thread, and the subscription block was executed on the main thread. So everything in this block was done on the main thread, or the Pikachu block was done on the main thread, and everything in the subscription block was done on the main thread. So both of those executed sequence. We come down here to the background thread signal. You can see the scroll block was executed on the main thread. So all this, the work in here was executed on the main thread. But come down here, you can say the scroll block, subscription block was not executed on the main thread. So simply by calling deliver on, you say deliver these results on the background schedule. I want these things computed on the main thread, but I want the results delivered on a background schedule, or whatever schedule you want. And similarly, you come down here, you see this start lazily with scheduler. You start it with a background scheduler. You can see the block was not executed on the main thread here. But then when we subscribe, we say deliver on the main thread scheduler, and the subscription block is executed on the main thread. So this is really good because you're doing GUI stuff. You can't update any GUI stuff from any thread other than the main thread. So you might have, like you want to download an image for a table cell or something, you have to download it over the network. So you want to download that asynchronously, but then once it comes in, you have to set it on the main thread. So you'll do this a ton. So do some work on the background, and then when that work is done, do something on the main thread. And usually this involves blocks, dispatching onto a background thread, and then dispatching again on the main thread. And this is a whole lot cleaner. And a whole lot more, it's pretty explicit too, like what you're doing. So these schedulers are very convenient for doing any current work. And you can just hop schedulers whenever you want. So this subscription could be on the main thread. You can have another one. You can say deliver on, subscribe on another thread. Because these signals are immutable. This deliver on is creating a new signal. And we're just calling subscribe next on that signal, which we're not putting on this new signal variable. So this lazy signal is never actually affected. So you can take this lazy signal and say deliver on another scheduler and get the subscription results on another scheduler. So schedulers are, I think they're very powerful. If you've ever done any like Objective-C and had to do any asynchronous or concurrent stuff, then you'll definitely like doing this a lot better than normal. Again, you're doing GUI work, so you have to make sure a lot of your stuff is only done on the main thread, like any UI updates. And again, this trip me up sometime. Deliver on affects where it's delivered. So you have to start the scheduler, start the signal with a scheduler to have the signal block execute on a scheduler. You can't say deliver on and expect the signal block to be delivered on a thread. It's the results after when you subscribe. So just remember that deliver on affects the results that are delivered, not the actual work inside. So create a signal, and that signal will never, you can't execute that signal asynchronously by calling deliver on. It'll only affect your return. So cognizant of that. And now we move on to transformations, which, again, most everyone here is probably familiar with these. We don't have these in Objective-C. I mean, the foundation library has some really good functions for doing strings, pretty good array functions, but we don't have standard map, filter, take, flatten methods in Foundation. But they do have them in Reactive Chapter, which is good. And they work basically how you would expect. I have a bigger example up here. And we have this hand gesture recognizer. So what we want to do is move a view up and down on the y-axis. And we want to show the current position of the view. So we just create this hand gesture recognizer. We get a signal from the recognizer, this gesture signal, which adds the recognizer to the view. And then we want to transform this signal into something else. That's what we just call map. And again, this is just probably like you're used to. It takes a object, whichever object the signal has, and you transform it. Here we're just doing some stuff to get the translation and set the recognizer. And then we return this value, this NS value, with this point, which is the translation. And this creates a new signal. Like you think of it almost like a list. If you map a list, you get a new list. You map a signal, you get a new signal. The source signal is untouched. So you map this, you get this new signal, this pan gesture mapped, and you bind this to the view's center. And one thing, if you're familiar with Objective-C, or if you're not, you have to return an object from all these transformation methods. And so CG point is a struct, and so you have to wrap this in an NS value, and it will unbox and box these appropriately for you. Because the center of the view is a struct, it doesn't take an NS value, but Reactive Program will unbox these things for you. So have to return objects. So if you have a struct or something you want to return, you have to just wrap it in one of these wrapper classes. So we bind this transform signal to the view, and then we take this map signal, we transform it again, now with this NS value, we just create a string out of this mapping. We take the original signal, we transform it, we get the state, we create some strings from the state, we return that state, we create some colors because we want to change the color of the view. We filter the signal because we only want to do something when the state is either changed or ended. We filter, and then we map, and then we return a color for the state from this dictionary we created right here. So again, you have this nice syntax. You filter, which returns the signal. You don't even have to worry about that intermediate signal, and then you map it. So this is as close as you get to function composition in Objective-C. And it's much nicer than having to hold on to all these intermediate variables. So then we have this color signal. We create this initial point. We bind this translation label. And this is something new too. You can merge signals. So this is one of the things when you're thinking about binding things. Maybe you have data coming from all different places. You can only bind a variable to one signal. You can't bind a variable to a bunch of different signals. So if you want to do that, you can merge signals into one signal. So we're taking this string signal and this initial point, because we want it to initially show where it is even before we move it. So we merge these into one signal, and then that returns the signal, and we bind that to the label. We bind this state to the state label. We bind the color to the view.
Question.
Yeah.
The RIC library, it doesn't support like a zip type operator?
It does have zip, I do believe. So here's our view. You can see our Y translation is initially set, and that is from this merge and this rect signal return. So this initial point, this return, is going to send this, and this value is immediately sent to this translation label. So that's our initial 284. And as we move it, you see our labels updating, our color change. We let it go. See our state label. So, and again, if you've done Objective-C before, like setting all this up in normal Objective-C land would be, it's not more work, but it's a lot uglier. And here, you're not really dealing with state. All the states dealt with for you. You're not explicitly setting flags or updating labels. You're saying, here's these signals, find them to the different views and labels, and just do all that for them. And so you have this nice reactive view that always tells you where the Y is, tells you the state of the gesture, and reflects the color. Any questions? So again, signals are immutable. Just like you would map a list and get a new list, you map a signal, you get a new signal. Or a lot of Ruby's. So you don't have any of this map bang stuff in Ruby that mutates your collection or your signal in place. So always immutable. And now, if you want to mess with it a little bit yourself, you can. I'll also go through and code this along with you. This is for the canonical example is a login form and making it react to user input. And I think it's a pretty good example because it sort of shows the different sort of paradigms and how you would set something like this up. So we have real quick. We just have a basic login form, name, email, password, create account button. I want to wire this all up and show stars for each of the fields to indicate their correctness, rather than put something in and try to create an account and then figure out if it's incorrect. You want to know if it's correct or incorrect as you're typing. Similarly, we don't want to be able to create an account if you have incorrect information. You don't want to make a request, say, oh, that's bad information. Kick it back and say, try it again. So we want to basically prevent invalid states. Let the user know that their password is bad or their name is too short, the email is not valid, and we don't want to let them create an account unless everything is valid. So we want to disable the account button until all the forms are valid and show the validity of each form as we're going. So up here, and so we want to transform this signal into an image, basically. So we've got these indicator images. And so we want to say, well, this text needs to go into an image. And so for the name field, you don't really want to say, I mean, you might want to say that name has to be longer than 6 characters or something. So first, what we could do is filter it. return a star. And so we've got to set up some values for each signal and map this to these indicators instead of going through this crazy source bid. Does anyone have the code, or is anyone? It's just you shouldn't have to install CocoaPods. The pods are in the project. Yeah.
Yeah, I got the same anchor on my setup too.
You should have had this.
Is it failing to load that config file, maybe? The Xcode config file.
Yeah, you shouldn't have had to install CocoaPods. So I put the pods in there. Usually, if the pods aren't in the library, you have to have it to pull everything down. But anyone got any questions? I'm assuming most of this makes sense because again, this is functional programming meetup. These aren't new paradigms. I imagine most of it. But do what?
It's just the syntax.
The syntax.
Very crazy.
Yeah.
Crazy.
Yes.
I guess FP people shouldn't be too condemned.
Yeah.
Especially Erlangers.
We're such hypocrites.
So. Yeah, so basically, map it, transform value,
That's the answer key.
yeah, this is the answer. So, what we want is to transform that text, and we want to transform it into a Boolean that indicates whether it's valid or not. So, we have this name field, we say length is greater than 4. We have email, we say length is greater than 6. And here it just has that sign. Obviously, if you really wanted to check the email, you'd probably use some sort of range, certainly not. But this is just for this. The password. Do what?
Use a real parser.
Yeah. That's like an official regex. Or you can use parser. Whatever floats your boat. For this example, this works. And then we said the password is greater than 6. And this syntax you haven't seen before, this is simply saying boxing a permanent number into an NS number, which is the object class that uses the wrap number. So it's a syntactic sugar for creating objects out of primitive numbers. And so then we create this block. And this is how you create a block without passing into a method. Again, it's awful syntax. Like, I can almost never remember this. Like, return type goes here, then like, where's the little caret thing go? I don't remember where the caret goes. And does the name go inside the parentheses? And then parameters. Then, oh, there's another caret. But this caret goes before the return type. Yeah, that's it. So we create this block here, and we pass this block to map for each of these signals and assign it to each of these inputs. And so start off, all the fields are invalid because there's nothing in there. As you type, the star updates based on the value of the signal. Email field will never be valid until it gets an at. Generally, there's an at, and there's not enough characters, so forth and so on. And password field has to be greater than 6. So we have very little code. We have a real-time indication to the user that, hey, you're putting in correct information, or you're not putting in correct information. Again, this is really how forms should behave. Like, you don't want to hit create account and then find out you did it wrong. You want to know as you're doing it whether your information is valid or not. So that's sort of the basics of that, transforming the text into a Boolean and then deriving its images from it. And now we don't want to be able to fire off the account unless they have everything correct. So move on. We've got the same. We're getting the images. Now we have this very nice combine latest reduce method, which you can think of this as a folder. Combine latest, it takes an array of signals and a block with a variable number of arguments. So you don't really get completion autocomplete on this block. It's a variable number of arguments. So it takes an array of signals, passes all their values into this block, and you reduce all those values to one new signal. So think of it as MapReduce old. So we're saying the full value for the name, the number, and the email signal all have to be true. And then we're going to use that to drive the correctness or the enabledness of the account, create account. Then we come down here and we have this back command, which you have not seen before. And this is used for like UI elements like buttons, things that do like a target action. And so you create this command, you say init with enable, and you give it this correctness signal. And this will automatically enable or disable the control based upon the value sent from this the signal you give the enable property. So the signal has to return a Boolean value for this to work. And then it has the signal block, which this is sort of hairy. You have this signal block which returns a signal. So you have this signal, you create a signal in here and return that signal. So we have this signal and we just want to fetch a picture. Normally we might have something to log into about just fetching a picture. We get this picture, and if there's an error, we send the error message. Otherwise, we send this image, and then we send complete. So this is our command. And we come down here, and command has an errors property that will let you get all the any errors sent by signal. So we say we want to handle the error here. And by handle the error, we just mean bark it out from console. And then we give this create account button as a rack command property, and we just assign the command to the rack command property. Now every time this button is tapped, it'll fire off this this block that we're given to rack command. So we've got that. We can run that. So you notice we start out, and immediately our create account button is disabled. Because all these are incorrect, so start typing away, blah, 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 that's correct. That's correct. And you see the account button enabled and disabled, depending on the correctness of all of it. And these units still working? Yeah. You see, you fire it off, it disables it while it's executing, and then re-enables it after it's done executing. So that's another really nice thing about using the wrap command code. You don't have to think about, oh, I need to disable this button because it makes an network request. I don't want to just be able to hammer on it and fire off a billion requests. It automatically handles disabling and enabling it for you while it executes and so on. Its methods. So now we want to actually do something when we tap that button. We'll do something with the result. So we've got our command, and we have this down here. We have another method on the button called rack signal for control events, and buttons and controls have control events, and like touch up inside or drag or whatnot. And we say this touch up inside, which is just a normal tap, and so we want to signal whenever this tap happens. We subscribe next, and we resign the responder, and this is just dismissing the keyboard. If the keyboard's up, we want it to be dismissed when they hit the button. And this is sort of how you might do a side effect. So this is just, there's nothing pure about this. It's purely side effects. So you would maybe create some other signal and do the side effects. And this you haven't seen before, this weakify and strongify. This is simply to keep from having a retained cycle within this block, because you're referencing self. It creates a shadow variable.
Are those decorators then? Or?
They're macros. I see macros. And they're just, it's syntactic sugar. For normally you have to like do I forgot that. I have a shortcut. It's like you have to create a weak variable up here, and you have to create a strong variable within the block so it doesn't be allocated. This is just syntactic sugar for make sure you don't end up with a retained cycle in the block. So we resign these all the text fields, make sure the keyboard is dismissed whenever the button is tapped. Then we have this image view. And we have this command, and it has an execute signals method, which sends the signal from this block. So in the signal block right here, the execution signals is going to send you this signal. So we come down here, we get this execution signals. We have to flatten it because it's a signal of signals. And we don't want to assign a signal to our image view because that's meaningless. So we flatten it down, and we get the actual image that we sent. And then, since we started it lazily on another scheduler, we did it in the background. So all this is being done in the background. We want to make sure when we assign it, it's assigned on the main thread. So we simply call deliver on, and say rack scheduler, main thread scheduler. And we bind that to the image. And right here, we just start up an activity indicator to show that it's something's happening. We add it, and we have this executing property. And this will send a value if the command is executing or not. So you get this number, which is just a Boolean, and we say if it's executing, animate the spinner. When it's not executing, stop the spinner. And so again, these are side effects. You have to just call this method start and stop. So again, we come in here, correct fields, we come in enabled, spinner, keyboard, and there's a picture of a chinchilla. And again, you can't hammer on this button because it's disabled until it's done. The spinner goes, until it's done. Then here it's like, oh, it's done. I'll stop. So we have basically 30 to 100 lines of code. We have a very, and you have to do more, but you have the basic workings of a very user-friendly login form, and you're really not dealing with much state explicitly. You're setting up these signals, you're transforming them, you're using this command to drive the enabledness of the button rather than saying re-enable it, make sure I disable it, then re-enable it. And so you're getting rid of all these normal stateful things you would do and just sort of letting the Reactive handle it with these bindings. So again, 100 lines of code, pretty much dealing with very little state other than these side effects of resigning the keyboards and starting this activity indicator. And yeah, doing this imperatively is not near as clean. And also, I'll show you later. It's not in this code base, but I have another project that has a lot of Reactive Cocoa examples. It just shows a bunch of different Objective-C things and how you do them in Reactive Cocoa. And I have how you do it normally, and then the Reactive Cocoa way. So I have, like this example, like here's the normal imperative way, which is stock Objective-C, and then here's the reactive crypto way. So you can compare and contrast, like, here is how you normally do an Objective-C, and here's the reactive crypto way. So that's the basic full example. There's a little bit more we can talk about. That goes into, I guess, some more advanced reactive crypto stuff. You know, we saw the combine, latest, reduce, which you think of as fold, basically. The wrap command, which helps you drive state for your controls. Yeah.
That's more of a step, actually.
Yeah, I mean, because you're giving it this array, and you're, except you don't get back a. I guess you don't really get them back combined like you would in like task where you get like a list of tuples or whatever. You return one object. It's like
you're not pushing the value onto another frame.
you are with this reduce.
And that's a zip.
Yeah. But I don't know, I guess not how I would think it was there, where you get back, you have two lists, you zip them together, you get both elements, the elements from both lists. You're reducing all these values to one single value.
You can use a function
To combine the lists. So yeah, that might be a better way to think of it. So yeah, again, it's taking a bunch of values and reducing them to one value, is what it's doing. Or a bunch of signals and reducing their values to one value, which is then this. Which was, we took all the booleans and reduced that to one boolean, which said in this field is perfect. And command, which again is great because you enable the signal and it drives the state of the button for you. You don't have to worry about that. It's sort of weird because you have a signal of signals, so you have to flatten the signal whenever you need to get the actual thing from the signal. So how you might do the side effects is create this other signal and just call subscribe next on it. You like dismiss the text fields or some other stateful thing. You saw you have this executing signal. That'll say values when the command is executing and not. You can use things there. And that was pretty much the login form. There is some more stuff we'll go over. And this is, I don't know if it's necessarily advanced, but it gets more into the guts of Objective-C. You have selectors in Objective-C, which are your methods, and you can actually get a signal for a selector. So if you want to listen, have a signal for the invocation of a method, you can say, back signal for selector, pass it to selector, and it'll send you a signal with the arguments in a tuple. So I'll show you that real quick. So we got a table lead here. It's just going to show red, green, and blue. We say rank signal for selector, table view, did selector on the index path. Gives us a signal, we map it. Gives us a rack tuple, which is basically just tuple like you're probably used to. It can go to 5, I think, 5 tuple. We get the index path, which is the second value. So table view would be the first value. This index path is the second value. And we return just the data array, the index from our data array, and an index path. And then here's another one. You can lift selectors, which is basically lifting the selector into the reactive world. You say, I want to lift this selector. You give it a selector. Here we're saying we want to form a segue with an identifier. And you give it signals to invoke to pass the selector. And so now our selection signal, which we get from here, we have this signal, which is simply returning nil, because we don't care about the sender parameter, but we have to give it something. And then this is the nil terminated list. And then just table view stuff, normal, how you set up table view.
This is just a random question, but everybody's how these tubes are.
Or that they just go to 5?
Yeah.
Okay.
They had this stuff somewhere.
Yeah.
I did the library class, so they had stuff somewhere. If you look at like C#, the .NET library, I think they go to 7 or 8. Stuff someplace. But what you typically do is if you need more, then you create a couple, say five tuple in this case, where the last spot in the tuple contains another part.
Yeah. Yeah, and I haven't had one where I need more than 5 yet. And they have like the reduce block, the combine latest reduce is a variable argument block. It'll take 15 parameters. Which if you're passing 15 parameters in a block, like what are you doing with your life? Yeah, here's the table view. Red, green, blue. I mean, very simple. We're driving this behavior by getting a signal from the selector instead of actually implementing the selector in the next path like we normally would. We just re-implement it and we leave it empty. And we actually handle this here. We want to handle it with a signal. And then we lift this selector, which is going to form this. It's like binding to a variable, except it's going to form the selector every time one of these signals sends a value. And so every time this signal sends a value, which is every time we tap the table, we're going to get this value and we're going to segue to that next view controller. So this is what Reactive Cocoa way of doing a little more fun stuff. So you can get signals for selectors. You can lift selectors, which again is just lifting selector into the reactive world. Things are like binding to a variable, except it's going to invoke the selector for this method with the given signals every time the signal send a value. So you might not really need to use that too much. It's sort of like there's the way you can do it. You can start with subscribe next and do a lot of stuff in these subscribe blocks because it's the easiest way to get to your data. This is sort of like the more idiomatic way of doing it. It's like you can write do syntax in Haskell and whatnot, or you could use bind and just get rid of all these intermediate variables. So this is sort of more the idiomatic, correct way of writing it. You don't want to have subscribe next is like the base way of entering in. There's usually a better way to do it, and this is one of those better ways, lifting the selectors away. And that's pretty much it. Like I said just a bit earlier, I do have an example project that shows a bunch of different examples and how you do them comparatively. That's this Kilo's RIC example. And you can also go to the Reactive Cocoa GitHub page and learn probably far more than I would ever be able to tell you, and probably better than I can tell you. The guys that implemented it are incredibly smart, and they've got a lot of good documentation. Some of it is, when I was first learning this, I didn't find the documentation very helpful because I hadn't done any functional programming. This was my first introduction to any sort of functional programming. So I was like, what are all these map and signal and stuff? So if you're already familiar with this stuff, the documentation will probably make lots of sense. You'll be like, oh, this makes sense. And it helps if you're familiar with Objective-C too. But if you're not very familiar with it, I tried to make it more familiar for people that have never done functional programming, that have only been iOS developers. That's what the RIC example is. So that's pretty much it. Any questions? I'm guessing not many people in here write iOS apps. I mean, I write iOS apps all day long. That's my job. Right. I write them for fun too. So I didn't know if do what?
Yes, seriously. Yes.
Yes. Yeah. I enjoy writing Objective. I mean, I still enjoy Objective-C even after I started doing Haskell and getting exposed to the actual real functional programming. I mean, I find it still a compelling platform.
So do you use the Reactive stuff for all your iOS stuff? Or
Yeah. Like I do all mine. I haven't quite got them converted over at work yet. I've done this presentation. I've talked about it at work. They know it, but it's one of the things where we're doing these work for these clients. Who knows who will have it afterwards? So it's sort of teaching like, well, they'll never understand this if we give it off to someone. So I'm trying to work it into work, but I used it for all in person stuff. I really wouldn't want to write anything about it if I didn't have to. But yeah, I mean, I enjoy iOS. Like I said, the iPhone's a compelling platform still. So.
How much friction does that give you in terms of iOS updates? Like, does this delay you in updating from iOS 6 to 7, kind of things like that? It's not at that level of the API, I guess.
No, there haven't been any problems with updating. I mean, again, it's Apple. They can change whatever they want, so
Right.
they could deprecate something or blah, whatever. But I mean, these guys are iOS and Mac developers too. They know, they're aware of these things. So it's not like, I don't think you have to really worry about something like that happening.
So since this is actually Cocoa stuff, you could write it like a Mac desktop app.
Yeah, I mean, they're actually Mac developers. They work for GitHub, and they write the GitHub for Mac app. And yeah, so yeah, it's for OS X too. I focus on iOS. So if you want to do Cocoa desktop apps, or if you want to run it on the server, whatever, run Objective-C on your server.
Why not?
Yeah, why not?
Suit our APIs.
What could possibly go wrong?
So, I think I had this in another slide that I took out. There's a language called Elm. I don't know if everyone's aware of that. You should be aware of it. It's pretty awesome, and it's a functional reactive language, and it's for the web. It's for like front-end web dev stuff. And it's actually implemented from the ground up as like a functional reactive language. So you can sort of see how it should be by looking at it.
It's written in Haskell, and
Yeah.
it's a JavaScript compiled target.
Yeah, it's really, really interesting. If I knew more about that, I probably would have said I'd do a presentation on that, but I haven't got enough time to really poke at that to do much of that.
Cool. Thank you.